So today we're going to talk about intermolecular or van der Waals forces, both of which are synonymous for each other, and these are forces that attract molecules to each other. The strongest type of intermolecular force, here I've illustrated, are hydrogen bonds. So I've drawn these hydrogen chlorides, and I'm showing you through these dotted lines how the chloride and the hydrogen want to attract to each other because hydrogen is so positive and chloride is such a negative electron hog. So moving on from hydrogen bonds, the next type of forces are dipole-dipole forces. These forces occur between any polar molecule and illustrated again here, hydrogen chloride molecules. This happens again in hydrogen bonds, but is more clear with dipole-dipole forces. So these molecules will attract to each other because the positive and negative ends will want to connect. So between hydrogen and chloride and hydrogen, and etc. These are how dipoles are illustrated above the hydrogen chloride molecules. They always go from positive to negative end. The weakest type of intermolecular force are London dispersal forces, and these occur between molecules that are nonpolar or are even in charge. For example, iodine here are iodine molecules. For a split second, these iodine molecules will form dipoles because they'll become uneven in charge on but one end or the other. So this momentary dipole formation causes the iodines to want to attract to each other just for a split second. These intermolecular forces all make the phase, or one factor contributing to the phase of an element, which directly affects melting and boiling points. How this ties into periodic law is by the melting points and boiling points traveling through period, going horizontally on the periodic table. They rise up as you move horizontally across the periodic table, and then drop back down with the noble gases being at the lowest boiling and melting point.
Intramolecular forces are forces that keep a molecule together by attracting atoms together. The main three are ionic bonds, covalent bonds, and metallic bonds. Ionic bonds happen because one atom, it really wants to be full. It wants its valence electrons to be full shell. And another one, since it's so close to being empty, it just wants to be empty. And so it'll kick that one out and this one will take it in. One of them will be positive, the other will be negative, so they'll be polarly attracted to each other. Covalent bonds happen because both or all parts of the molecule want to have a full valence shell. So they'll just share the electrons that they need to be full. So here's where it shows from water. Metallic bonds happen because in a sea of electrons, it's so easy to form bonds, and so it just takes two metals and they'll bond together and form an alloy. So here's the periodic table. Metals take up a lot of the periodic table. They go all the way from here, and they cover most of it. And so this is where all the metallic bonds take place. Metallic bonds are between two metals. And ionic bonds take place between one of these metals and a non-metal, which can be from anywhere here, and hydrogen. And covalent bonds happen, it can't happen with any metal, so it's only between non-metals. So hydrogen and everything above this.
Polarity is the strong bond that brings two elements together. It could either be polar or non-polar. Polar is when two elements are uneven with their valence electrons, but then over here with two hydrogens, they are nonpolar because they both have full valence electrons. So there's no dispute between the two elements.